Hello, and thank you for joining again. I have now a green screen, and that was recommended to me by virtually everyone in order to get my box down here out of the way of other things. So now I've got that, and it's actually pretty cool, and I'm looking forward to playing with this a lot. But welcome. These sessions I have been doing for the past several weeks on deobfuscating JavaScript programmatically. We've been going through the JavaScript obfuscator tool, which is JavaScript-obfuscator. You can find it at obfuscator.io, and going through all of its options in order to figure out what it does so that we can programmatically deobfuscate it. We've been doing that. All right, where I work, Shape Security. This has been something that has been top of mind for years now, is the protection of JavaScript source code. And as a result of that obsession, we've been trying very, very hard to figure out all the different ways that you can manipulate JavaScript and hook into it in order to figure out how to protect it. So we've been doing that here on the stream together, you and me, figuring out how to do that against obfuscator.io, mostly as an example, because these techniques are things that you will see commonly used trying to protect JavaScript in general, and it serves as a good test bed for deobfuscation. That way we don't run into any DMCA concerns as I try to tweak legitimate real-world source code. So let's go over what we did last time, because we ran into some hiccups towards the end that I've since fixed, and we'll just run through that. So this is the code that we have. This is the end result, the obfuscated code. Let's see here. So this is what we start with. It's a very, very simple contrived. Let me turn this down. It's a very, very simple contrived bit of source that tries to exercise a bunch of different JavaScript features so that we can see how this obfuscator obfuscates things. We obfuscate it with here. So we're using JavaScript.obfuscator as the npm package. We're reading in the default obfuscation options, and this is everything you can do with it. Control flow flattening, dead code injection, debug protection, identifier names. You can choose how you want them to be generated. We've gone through and automatically deobfuscated just about everything except for this. Dead code injection. Nope, I lied. We didn't do dead code injection either. Please video about RC4. What do you mean RC4? Well, let me type. So Rusafi, I'm not sure exactly what you mean by RC4. If you mean stage 4, that's what we're going to be jumping into. I just wanted to touch over some of the changes we did in the last one. So deobfuscate here. We ran into an issue with an infinite loop. I thought it was due to the replace here, but it was actually due to the convert computed to static. There is a slight bug in this, or behavior that is undesirable, where if it tries to replace a computed member expression or some sort of a computed property with a static property, but it is invalid, then it'll get into an infinite loop because it'll keep on finding that computed member, computed property, but it will never actually change it to the static equivalent. So this is bypassed right now because I've addressed the invalid property replacement. So I haven't actually fixed the bug. And it's not something that you need to really worry about yourself because most properties are going to be fine if you're going through this deobfuscation process. So it's workaroundable. I'll fix it eventually though. But now you can see, let's see, original obfuscated, all this junk. We can now run our let's see, stage 3. So node deobfuscate, which will take in that and output this. So this giant blob of junk, 5,774 characters, is automatically deobfuscated with this program and returned to virtually its own, its original equivalent. So going forward, let's check out the JavaScript obfuscator code flow fattening, or code flow fattening. That would be an interesting obfuscation technique. Control flow fattening. So I've made a copy of stage 3 right now. You can do that yourself by cloning the repository in chat, and you can follow along, and we can see how well this works. So let's see, obfuscate. I've turned off the other obfuscation techniques so that we can hone in on control flow flattening just to see what it's doing. So let's see, our original right here. I did have to add some additional logic in order to trigger the control flow flattening. I need a better way to describe this. CFF, control flow flattening, CFF. Whew, this is gonna be tough. I had to add some extra logic in here so that it would do something. Otherwise, it was just not changing the code much at all. So now let's go to obfuscate. Let's go stage 3, copy. And now let's obfuscate that. So original obfuscated. Format. You can see what's happening here. So first off, we have this new data structure up here, which includes some functions, some strings, this strange looking string right here. Hey, Ashke. How are you? And we have the constructor here, which is largely the same. The code down here, which is largely the same. Actually, no, that's not true. We have new calls to C here, which is our object up here. So we're getting our strings in this new object, which is strange because there is already a mechanism in JavaScript obfuscator to extract strings into another data structure. Maybe it's just a composability of it, so it makes it harder to understand where things are coming from. But now we have this this loop here. So we have this, so KJNO. So we get this value, we split it on the pipes. We start off at an index of 0. And we go through each index and then execute the logic in the appropriate section of this switch statement. So what it's doing is it's splitting up the statements in a function that is large enough, and then going through them via this switch with its order presumably shuffled with this value here. And it looks like, so we have the if statement here. So our original code was over here. Simple stuff, we've already gone through the class greeter. This greet function is the only thing that's targeted right now. So we have a console log, hello, the target. If the target is world, it says, it's beautiful out, isn't it? If the target is reader, it says, I like your hair. Says something else, and then says something else. So what we see here in the obfuscated version is that the comparisons are extracted into functions on this object. So it even duplicates the comparison functions, which is actually kind of annoying. It would be smarter if it would at least keep the same comparisons. That might actually be a good way to optimize code, improve the output size, but oh well. So it extracts the comparisons there, and then throws everything in this switch statement. This is kind of cool. This is the type of obfuscation that starts to be more effective because it's actively manipulating the structure of the original source code and not just wrapping it or changing identifiers or extracting strings or anything like that. This is actually just changing the way the code is executing. It looks like something we can manage. Certainly statically, we can easily extract these things out. We've already done it with the rotated string array. We've gotten a value out and then have rotated or unrotated the elements in that rotated string array, which is going to be very, very similar here. But what I'm stuck on is the extracted comparisons. I mean, that's just kind of annoying and ugly, and I'm not exactly sure what the best way is to go about addressing that. So we could certainly statically grab these things and then substitute them here, but it's going to be hard to do dynamically because I don't think that I would want to base much of my deobfuscation logic on properties of this object up at the top here. Because one, it would be very fragile, and further obfuscations by JavaScript obfuscator could obfuscate and rotate the properties of that object, so it would be very difficult to do effectively. I don't know how to do this automatically. For consistent examples, I think we've already proven on this stream that it is trivial for us. Well, it is not complicated for us to write code that will extract things as necessary. But this is stranger. What might be useful? I haven't actually done any logic with diving into the properties of an object, and really I don't want to. Oh, let's work with the switch statement for now and get that simplified, and then we'll deal with the extracted comparisons later. All right, so we have this switch here. We have what do you call these? What do you call that? Labels? Case? What is that called? Anyone know? What is the comparison in a switch statement called? Case clause. Okay. All right. So these clauses, we need to extract these clauses and figure out the order at which to extract them and replace them based off of this string. And this string we have to get from here. We could just look for a string here that follows this pattern. That might be easier than trying to figure out exactly what this one's doing. I don't know. You have any suggestions? This is a fun one. All right, let's look for this pattern first. Let's get that string out. So we're going to need to find the, so this data structure is always going to be at the start. We can look for it there. We can extract that same string out by looking for first level properties that have a type of literal string expression, and then looking for a string that has pipes in it. I mean, that feels ugly. Ooh, and you know what? This will be even harder because this probably happens frequently for every function. It's probably not one central location. Let's see if there is. So let's see, original. Let's copy this out. So I'm just going to duplicate this and see what the ending structure looks like. original obfuscated format. So it still uses the same structure within the scope. But now we are going to have to figure out what property to read out of that object. Yeah, this gets much more difficult to do. Like, I was hoping at the end of all this, we would have a script that could just generically deobfuscate virtually anything that JavaScript-obfuscator threw at you. But something like this ends up being more complicated to do in a general manner without a much more complex bit of code. And that's exactly where you want to get with obfuscation, is to make it difficult to create a tool like I'm writing and then have it deobfuscate code over and over and over again without problem. You want to have manual effort involved every single time, so that it essentially it turns the cost versus value justification back on the attacker or the adversary trying to break this code, and has them figure out whether or not it makes sense to continue with this reverse engineering effort. So right now, if I was doing this and if I had this code changing every single time, this would be a giant pain, and I would probably go and attack something else, because this is a bit of work. All right, let's go through and look for while loops. All right, so the while loops all have the same sort of signature, I guess. So we can look for while loops that look like this, and then have the variables that are declared right before it. We will look for those. Okay, this isn't getting that bad anymore. One thing that I've also created in the past few weeks is a online demo for Shift Query. If you remember a few weeks ago, I was having a little bit of difficulty figuring out my queries live. So I made this in order to make it easier for me to visualize what's going on. So first, actually, we need to find the structure we're looking for. It's the while statement. We have a test that is a unary expression, two nested unary expressions, and an array expression. Let's see if we can grab that easily. Let's go to our Shift Query. So we're looking for while statements. So we've got two while statements. Let's throw another while statement in there that we don't want. While true, so that we can figure out how to better deal with these. Oh, interesting. So even if we get the while statement, we're gonna have to figure out the nodes right before it too. And I wonder if that's easy to do with the sibling connector here. Huh, I don't know, we'll see. All right, so we have while statements. While statements that have what? Test, so unary expression. So I want test.type unary expression and test.operand.type unary expression. So while statement dot test. Is that something that I can do? While statement, no, that's not gonna work. All right, so now I get all the tests there. That's not what we're looking for. I want the direct descendant of the while statement, and I want it where the operand.type equals unary expression. Does that work? Yeah, cool. All right, so this is actually already getting what we're looking for, but it will catch other things. Like not true. Oh, that's because that is not. What is that? Is that not a unary expression? It is. So operand.type. So while test unary expression, type unary expression. So is this already going one level deeper than I'm expecting? Man, I need to get more familiar with these queries. All right, well, it works, and you know what? We'll deal with it because it works. So that's getting us what we're looking for. But now I need to get the nodes just before it. Let's see what we got here. So following sibling. So I want, so I need to be able to, I want to select that node and its sibling. Is that an and? No, I think that's only looking for things that, oh, I know. Let's see here. So I want the while statement, and I also want, let's see, a variable declaration statement. Is this gonna work? It's not gonna work, I bet. So I'm still getting the while statement, which is probably appropriate. I don't know, my strategy here is basically trial and error. Anyone want to become an expert on the query syntax for ES query and shift query? That would help, because clearly I need to brush up. All right, so, oh, I know. So we will look for the function body that has this. Is that gonna work? Why is that not working? Did I break this? All right, so it's not broken. And I'm getting, oh, I'm getting an actual unary expression. That's why I'm screwing up here. Huh. Oh, I know. Dot test dot operand dot type. All right, so now I've got those while statements. So I've got the while statements. What I need now is the function body. So I want the, what do I want? I did this before and I forget what I needed to do. So I want this, I want the function body. So that means that I need a function body that has a while statement. It means I can't actually select the parent, which is something that we can't do in CSS either. So this query syntax is limiting me because it's based off of the CSS CSS selectors. All right. So I have the while statement. I don't know how to do this unless I traverse through the entire AST, look for the while statement, and then grab its parent from there. And that seems ugly. But we'll do it so we can move on. All right, so we get our while statements. Let's go to deobfuscate. Let's get rid of all of this stuff here because we will add it later. Or actually, this deobfuscation is probably going to stand on its own and will have to be manual unless we do some more magic with shift refactor, which I would like to do, but not going to do it today. All right, so we want to refactor query. We want to get these while expressions out. Now we have our while nodes. And now I'm going to want to traverse through the entire AST in order to find the function nodes. And this is ugly. I don't like that I'm doing it, but it is what it is. Shift traverser. Let's see. I don't even know what my own project is called. Whoops. Shift traverse JS. All right, enter. And we get a parent somewhere, right? Yeah. All right, traverse. So I've also updated shift refactor to take in the source as well. I'm going to be dealing with the actual AST. So I'm going to parse it out here and then pass that along. So now I'm going to want to first traverse the AST, enter, works, right? Node parent. So actually, I don't even need these. Oh yeah, I do need the refactor. So I've got my while nodes, and now I need to grab the parents of the while nodes. So if while nodes.index of node is greater than -1, then we have found our node. So now let's see if this actually works. Parse script AST. All right, console log parent functions. Let's also log out our while nodes, make sure we're actually doing something useful, and get rid of that. So node deobfuscate. Tree is not defined. That makes sense because it's not called tree there. All right, so we have while statements, and now we have other while statements. Parent functions. It's because I need to push the parent. Cool, now we have the function body. And now that we have the function body, we can use this to grab the variable declarations to find the string that we're looking for, and then grab that from that object. Okay, so we got our parent functions. Now let's take a look for our object up here. So this was created at the root level of the, no, why was it created there? No, JavaScript obfuscator. Like once you start digging into some of its functionality, it's pretty cool. Like this, I would love to see how this actually works on a much larger program, whether or not these are individual data structures that are created all over, or if there is just a central location and it just places it up at the uppermost scope. All right, so now we need to find the first variable declaration in our function. So let's see. What is this one? Let's see, function body. Let's see. So script, statements. Ooh, can we do this here? Yeah, that's not gonna work. Oh, well, that's a shame. We can actually just grab the first statement easily ourselves. So we have our AST. Let's get our first statement. Data object equals AST.statements. Whoops, that's not what I wanted. AST.statements 0. So that is going to be the root node. Now it's Babel. We need to go back to shift. So we have our expression. So we have this statement. We need an expression. That is a call expression. We have callee body statements. Callee body statements. And the first statement in there will be the variable declaration statement. And we'll need the declaration and declarators out of it. declarators. And the first declarator there is going to be our data object. All right, so we have our magical data object at the top of this. So now we have our function bodies where we have our while statements and the variable declaration statement that includes the reference to the key string, whatever you want to call it. We have the data we need to do something useful. So now what's our strategy? We could grab, so we could take all of the statements in each case clause. Well, I don't know how to actually refer to case, I guess. So each of the statements here, and put those into a list, and then use the indexes that we parse out of these, and then just reorder the list, and then throw those statements at the root level of the function, which we already have. All right. That's cool. That's not bad. Let's see. So we might as well grab a function that takes in a key string and a list of stuff. List of statements. What does a switch statement look like? So variable declaration, class declaration. Elements, let's see, method, body, statements, while statement, body, block statement, block, switch statement, discriminant, and the cases. Okay. Oh, cool. So we actually already have the cases all ordered. So I haven't actually seen an instance of this obfuscation having more than one statement per switch case. So it might be easy for us to just reorder them here, since we already have a list and that includes everything. And then once we've reordered it, then we just map over it and extract the statements within. Okay. So now we need to find the, all right, so we need to find the key string. Okay. We're actually going to be doing that twice, and it's always right before the while statement. And it appears as though the entirety of a block is included within this while statement. So actually just at the root level, we just need to decompose everything within it and then up-level the statements. So actually we just need a function body here. Function unflatten. I don't know. It's actually... It's making it flatter. This actually, I come to think of it, isn't doing much flattening. It was already flat, and even the branches, it didn't really flatten in any meaningful way. I don't know. Well, we'll live with this name for it for now. All right, so we have a function body. We need to get this. So variable declaration statement, we have a declaration, declarators. All right, so const variable, const key string equals function body dot body. Oh no, function body dot statements. The first statement and the declarators, and we need to get the first. We could get the second too. It looks like the second is an offset to start with. I did mention before that it's a good practice to treat magic variables like that in obfuscated programs as meaningful, and this certainly does look meaningful, but I'm going to ignore it because they're both 0, and I don't really want to deal with it right now. Just know that the magic exists out there to deal with it, and imagine it being done. All right, so first variable declarator, we need to get the init there, and we have a computed member expression, and we want the object of that computed member expression, and the expression therein, we need this. So that is the first variable declarator. We have an init callee object expression value. Callee object expression value. Let's see if this gets us anything. This is a monster. That's something that I should probably add to shift refactor as an easier way to grab deeply AST nodes. And ideally, this would be something that shift query could do. I'm not sure I want to touch that much because the project that I maintain is just a strict port of esquery, and that's kind of a big project. And I don't think I'm going to be doing that. All right, so we have so let's see. So we have unflatten. Now let's unflatten. See what we log out here with our parent functions. The first one. Think it's gonna work? It worked. Oh, I just assumed that there would be some sort of problem in this monster. So we've got our key string now, or we've got our key string property name. Key string property name. Okay, so now we have the key string property name. That means we can get it out of the data object, which is up here. And we can get that via declarators, object expression, properties. So we have the properties here. We'll have to map over the properties and grab the key string itself, or the, what do you want to call that? Do you have a better name? If anyone has a better name, if anyone wants to help me name things as I'm going, please, that would be a great help. All right, so we have the key string property name. Let's go to data object. We're going to want to map over the properties. So where is our data object? What does our data object look like? Just log that out. Variable declarator. So we have the declarator itself. That's key string equals data object. So that's the declarator. Where are we? So declaration statement, declaration, declarators, we are right here. So we need the init properties. So init properties, and what we need to do is filter through everything that looks like our value. So that is, we need name value. So .name .value equals key string property name. Let's see if this works. It works. Oh man. Sorry. Sometimes I get amazed when code I write actually runs on the first try. I don't know. Maybe it's just me. Maybe all of you are just the most amazing programmers in the world. But I get excited when things work. All right. So we have the key string, which means that we have the ability to split that up and find the order of our statements in the switch statement. It would be so much better if we grabbed this index and we grabbed this delimiter so that we were able to adapt to different indexes or different delimiters. We can leave that as an exercise to the viewer if you want to do that yourself. All right, so we have the key string. Let's see, order equals key string dot split pipe. So now we have the order that we need to work with. So let's see. Let's get the statements that we want to return. So RV statements, return recreational vehicle statements, return value statements. Sorry, it's a very, very bad name for a variable, but we'll work with it. All right, so we need our cases down here. We have the function body. So we need the while statement. We could query. We could pass in the parent function node, or we could use shift query in order to query for the statements there, but I'm not sure if shift query guarantees the order. We'll just look for it directly. All right, so we have our function body. Let's see. Const switch cases equals function body. Turn on the music again. Okay, we have the function body. Where are we? All right, so we have the function body. We can get rid of, oh no, we needed those statements. Dang. Let's see, statements, data property. What we don't need it, this is this right here. So class declaration, class element. This is what we're looking for. No. This one. Method, body, statements, while statement. All right, so the first index of the statements in here. So we have the function body. So we need statements 1, which gets us our class declaration. Wait, no. Oh, we're down here. Oh, function body. All right, statements. Yeah, we're good. So we still want that while statement. And then we have the body block, statements. And we're going to have, so body block, function body, statements 1. Okay, so that's here. And then body block statements. And we've got a switch statement with cases and a break statement. We don't need to worry about the break statement. So let's just grab the first statement in that block. And we have this, now we're at the switch statement. And we want the cases. So we actually ignore the discriminant because it's not actually doing much of anything. Yeah, we would have to worry about this in case this changed at all and we're dealing with the index. But since both indexes are 0 and it's just doing the same thing, we're going to ignore it. All right, so we have body, block, statements, 0, cases. Ooh, you know what this would be cool? If I had it in shift query or something else that allowed me to just click on something and give me the dot property string to get to it. Maybe some other time. All right, console.log switch cases. Let's see what it looks like. Ah, keystring.split. Oh, because it's the value. Keystring.value. What happened? What is keystring? Do I not have a keystring? No, we logged it out, didn't we? Data property, it's the first value there. Yeah, because we're filtering. Oh, isn't there a find or something now? A find that is basically filter, except only grabs 1. Yeah. So we can get rid of that and just use find. All right, so now we have our keystring, and that should be less of a problem now. Keystring.split. Oh, because we still have a data property. So it's a data property expression value. Keystring.expression.value. There we go. And now we have our case statements. So we have our case statements. We have our order. So what we need to do is, so we could just grab the index. So going through the order. Okay. So order is a list of indexes for an array. So we can map through that, grab that index, and then grab the appropriate index out of switch cases. Let's see if this actually works. Console.log, so we have switch cases. And now let's see our RV statements. Are we even gonna be able to see that? Okay. So we have, starts off with expression statement, continue statement, if statement. expression statement, if statement. So it has changed the order. Is it the right order? So we should have a expression statement, if, expression, expression. So expression, if, expression, expression. We have reordered based off of the key string. So what I was referring to there is right here. So we have expression statement, if statement, expression statement, expression statement. And in the obfuscated version, we have expression statement, if statement, expression. So it just shuffles it around. So now we have our reordered switch cases. Let's rename that. We still need the statements out of it. What was I going to pass in here? Statements. Oh, that was when I thought I was going to pass in just the key string and the statements to reorder, but instead I'm doing everything on the function body. All right, so we have reordered switch cases, and we could actually just map over and grab the consequent, the first statement in the consequent, because the continue doesn't matter. So let's see. Let's map over. Sorry, I'm using ugly shorthand for a lot of these arrow statements as opposed to writing out the variable names properly. I'm sorry. Let's see. So we need the consequent, which is just a list. So let's grab the first index out of there. What's the problem here? Why are you complaining? I need another thing. So this should give us a list of new statements that we can replace that function body with. Yep, we have our statements. All right, so we have our function bodies, or we have our new statements. So parent functions dot for each so fn dot statements equals unflatten fn. So this will redo the replace the body of the functions with our reordered statements, which hopefully works. So let's see. So refactor our print. I'm not sure if I have to do anything before dealing with that. It works. Look at that. We still have our data structure up here, but we have replaced all those statements in the right order. Refactor dot convert computer to static. We still have references there for the comparison functions, and that is kind of a whole different beast that would require a different effort. But I'm feeling much better about this whole thing. That was easier than I expected, and I was kind of expecting this to be kind of an ugly pain. All right, so now let's get rid of greet 2 since we don't need that. So node obfuscate, node deobfuscate. So now we have our function here. Let's output, pipe that to output. Ooh, output.ps, that's not going to be effective. Node output. So it's running through it. Fine, it works properly. Let's run our original just to prove it. So hello world, it's beautiful out, isn't it? Hope you have a good day. I've run out of things to say. Hello reader, I like your hair. Hope you have a good day. I have run out of things to say. Beautiful, good day, reader, hair, good day, and it works. Next step would be to just remove the where is it? That data structure up at the start. And if I need to update. So npm package JSON shift refactor. What version do I need? So I have updated shift refactor to 010. That's it. to account for some of the bugs that we were dealing with in the other streams. So it should be able to pass in the data object node to delete and have that work fine. Let's see if that works. So let's see, refactor dot delete data object. Oops. So deobfuscate, and we got it. Oh, we still needed that data structure to deal with our extracted comparisons. So that was a little bit premature. Don't have enough time to deal with that. But what would be a good way to deal with that is to, I need to have some sort of evaluation concept in here so that we can inline pure functions that are simple enough, so that when in a situation like in a situation that requires, I don't know, a simple value, we can just inline those comparison functions where they were before. Although at the end of the day, when it comes to deobfuscating this, I think the vast majority of deobfuscation is already done by getting rid of these switch statements. So if I were actually dealing with this, I would probably just hard code in some logic that would deal with these comparison functions. I don't think it's worth automatically replacing those and trying to get too close back to the original code at this point, because I was impressed that we were able to do that for as long as we did. That is rare. To be able to go from manipulated code back to the original code with all of its intent intact, that's pretty rare. So I think we were lucky, and now we've gotten to a point where we just have to be happy with getting to a good enough spot to move forward and not worry about getting back to the original intent. Cool. Well, I think that just about does it for this stream right now. I will commit this stuff, throw it up on GitHub, and go from there. So if you've played around with these projects at all, if you've cloned it and tried to execute it, I would appreciate any sort of feedback to make sure that things are working properly. A lot of this stuff so far has been me hacking around, and things work on my machine, but if they don't work on yours, then I want to know. All right. Anyone have any questions before we close out here? I will just play around for a little bit, let you stew. Or if you have any interest in making these UIs easier to use on mobile and more functional, that would be fantastic. Because this is a big portion of hacking JavaScript, is manipulating big ASTs. And the ability to query, and also, so query, the shift query is very, very handy, but what would be very, very great on top of it is to be able to more succinctly query for the shape of objects. So like the types of functions that look similar to something. So if I could write a stub function and use that as a query, that would be fantastic. Because then I wouldn't have to think too much about the query. I could just write out, let's say, like so if I'm trying to I don't have any good functions here. Never mind. All right. Well, I guess that's it. Thank you, everyone. I appreciate you watching. If you have any questions, reach out to me on Twitter at JSOverson. And now that we are... Oh, we're not done. Oh, we've got one more out of this because we can do the dead code injection. Ooh, that'll be cool. Ooh, that might be hard. Let's go check out that real quick. So let's see. Obfuscate. false. Dead code injection? Oh. So let's see what this does. Node obfuscate. Original obfuscated. This didn't do anything. That sucks. We need to figure out what structure of code leads to dead code injection. Oh, it's probably the threshold. I don't see any dead code. Oh well. I'll play around with that, and we will deal with that next time. But I have a sneaking suspicion that we're not going to get very far deobfuscating or removing dead code unless we build some level of evaluation, some sort of evaluation tool. So that way it'd allow us to evaluate what JavaScript would do if executed, but statically based off of the AST. And that would be exciting. All right. Thanks, everyone. I'll talk to you next time. And done.